So this is essentially what I plan to cover in our today's webinar. First of all, I'd like to introduce, the DFM as a concept. I think, most of you guys who have joined would typically be aware. But what I would like to throw light on is how, DFM has been essentially being done, till now in the industry, and what, new approach we are trying to bring in with DFMPro for NX and how you can benefit from it. After that, a quick overview of DFMPro for NX, just to set the scene for our demonstration, as it will essentially give you, a pretty good idea of what we are trying to do and what the concept is. And once the demonstration is done, we will essentially have a quick question and answer session to answer as many questions as possible during today's webinar. So as I mentioned, let's quickly go into the introduction of DFM and what we are trying to do or what we have learned so far, throughout our journey of DFMPro. Now, DFMPro as a solution, it has roughly been there in the industry for around 10 years now. And when we started, essentially, we started, working with a few clients, getting their feedback, and building a solution essentially targeting the design for manufacturability side of business. But as we worked closely with different customers from various domains, what we essentially learned is that although looking from outside, the nature of the business as well as the products that these clients or these organizations produce, they are definitely way different. They differ a lot in the nature. But essentially, the challenges that these organizations face in terms of this design for manufacturability process are essentially common. So there are essentially four main challenges. First challenge is meeting project schedules. What we have basically learned while working with these customers is that delivering products on time is becoming a challenge because of the requirement from the consumers of having new products released or with different features released within a year. Typically see, especially in case of the high-tech industry, we see that you get a lot of new releases or versions of products within a particular year. So all these pressures of releasing products on time are essentially getting affected due to design iterations and rework. And as we have interacted with many of these clients, what we find is that they are facing or trying to identify ways of addressing the design related issues early during the design cycle so that they can avoid the rework, as well as how can they essentially improve the productivity while dealing with complex and manual checking. So these are key challenges that they face in terms of addressing or meeting their project schedules. Second important challenge that we have seen is in terms of quality management, which means that how you essentially get your designs right the first time. Now, I know it's easy to say that everybody should get their designs right the first time, but especially it becomes difficult when you're dealing with new engineers who have just joined the team. Now they have excellent mechanical or respective backgrounds, but when it comes to creating designs which are suitable for manufacturability, organizations are essentially facing a challenge. And to couple with that, how can the downstream quality issues and regulatory demands, how can they be covered or communicated to the design engineers so that they get the quality as expected while releasing the product. Next, I think critical thing that we are trying to address is, or that we have seen, is in terms of controlling the production cost. Because especially when it comes to high-tech components or automotive interior components, what we have seen is when you're dealing with plastic parts, and especially complex plastic parts and complex plastic features, the tooling that essentially goes into it and requires a complex understanding of the features or the way it's going to be created is difficult for inexperienced people to understand. So how can we avoid expensive tooling and cost overruns, which essentially make it difficult for manufacturing teams downstream? And finally, in terms of when the product reaches or the design reaches the field, what we have seen is the engineering change orders that are typically raised in order to create these or modify these particular designs to suit manufacturability are humongous. I mean, just to give you an example, one of the a major aerospace and defense company whom we were talking to, what they basically highlighted is that in terms of the engineering change orders, it typically costs them like $8,000 per engineering change, roughly in that magnitude. And that is more or less a same, a similar trend that we have seen with different customers, not only in the aerospace or defense domain, but also working with different customers in other domains. So how we can avoid the engineering change orders right during the design stage so that you have a seamless design for manufacturability process. So what we say is that the above issues essentially can be checked by design for manufacturability and design for assembly. And the best thing to do is essentially address these things right at the design stage. So in terms of design for manufacturability, as all of you might be aware, it's essentially a broad topic. And what you need to, as an organization, keep in mind is some of the things which will help you to do it in a better way. First of all, design engineers need to learn from their existing practices as well as past experience, and ensure that they don't repeat the same problems over and over again, so that the efficiency as well as productivity of not only the design engineers but the downstream teams can be maintained. Similarly, everybody has to think in a holistic approach or take a holistic approach. I think gone are the days when from a design engineer's point of view, creating just a good functional design, and sending it across, was the norm. But nowadays, I think due to all the challenges that we have seen earlier, it's imperative to ensure that the designs are easy to manufacture as well as easy to assemble. Apart from that, I think it's also important to keep in mind the manufacturing tools, setups, and techniques right during the design stage, because just imagine if a design engineer has the know-how in terms of what capabilities in terms of tools are available downstream, either at in-house manufacturing teams or contract suppliers, then it becomes very easy for them to ensure that the features or the designs that they're creating are actually or will essentially be manufactured using those tools. And you are essentially reducing a lot of cost as well as procurement of new tools if non-compatible designs are sent downstream. And in terms of hardware components, what we have seen is many of the customers, especially in the medical industry, they're trying to ensure how they can reduce the variations in terms of various hardware components which the design teams essentially create. And there has to be essentially a standard way of creating hardware components so that the rationalization of these various hardware components is achieved. Otherwise, we are just creating a lot of different types of hardware, which it becomes difficult for the downstream teams to manage, as well as for the organization as a whole to keep a tab on in terms of cost. So to address this broad topic of design for manufacturability, what we essentially see is that you need to now bring in more of a DFX approach, where X could range from manufacturability, serviceability, cost, assembly, environment, fit, function, etc. So I think DFM has over the period of time evolved, and now it's more of a DFX approach, which you need to implement, and a lot of focus has to go in this to ensure that you are meeting your cost as well as product guidelines. I think, as I mentioned earlier, I think all of you are aware of DFM. There's nothing new that we are, trying to show. But the way in which DFM has been done traditionally is, something which is common across various industries. And with DFM Pro or DFX, what we are essentially getting is essentially a new and modern way of doing it. So, typically organizations have handbooks and guidelines built in within their framework or, design cycle. So what you essentially want to do is how those manual guidelines can be automated and built inside a solution, which the design engineers can quickly make use of to validate their designs. Typically, how can you train the design engineers? Because, it takes humongous, efforts in terms of not only, in terms of cost, but also in terms of time for various people to train the people or train the new workforce. And, how you review your designs quickly so that they are compatible for manufacturing. So what we have also seen, is that many customers typically, have, and I'm sure, that might be the case at your end where, once the design is completed, you gather the various stakeholders within a room. They basically go through that CAD model, see whether the features that are added are compatible for manufacturability. So you have people representing the advanced manufacturing groups, the design teams, the downstream suppliers, and then working together, you decide whether that is effectively created or not. And if not, then you add comments, and then designer goes back, makes the changes, and then you have a similar meeting just to finalize that particular design. So, this takes up a lot of time and also poses challenges, especially when, the manufacturing teams are located in different parts of the world. So, with this, I think let's quickly get into the DFMPro for NX and what you can expect from DFMPro for NX and how it essentially tries to address most of these challenges. So, I think the first important thing to understand is, when it comes to, proposing such kind of a solution, I think the first question comes is, what is the ROI, or what is the value proposition that DFMPro will bring in for a particular organization. So I think the first important thing to understand is the value proposition, and ROI is extremely easy to comprehend as it addresses long-standing challenges. In terms of this, what we have seen is, that 70% of the final product cost is typically determined right during the design stage. So in terms of generating an effective ROI, what you basically need to understand is, what are the typical challenges or problems that you are currently facing? How much of those essentially DFMPro can address in its current state, and how you can essentially bridge the gap of some of the custom requirements that you might have. So that then you get a complete solution in terms of DFX that we are trying to bring in with DFMPro for NX. And some of the key challenges in terms of ECOs are highlighted in front of you. I think this is something which everybody is aware of. But the gist of this particular slide is essentially just to highlight that ECOs essentially consume a lot of engineering capacity and also contribute a lot towards the tooling cost. And those are essentially resulted due to the design decisions taken right at the design stage. And essentially what you are trying to focus is reducing the number of iterations between the design and manufacturing teams, as well as reducing the time to market and saving the costs which are typically resulted due to all these things. So as I mentioned earlier, in terms of DFM as a solution or DFMPro as a solution, you need to look at it as more of a platform, and that's what the journey or the vision is. So what you are essentially getting with a DFMPro for NX within Siemens PLM NX is that you are getting a framework which is a flexible, scalable, and extensible open framework, which essentially allows you to build on the existing capabilities of DFMPro solution, wherein you are getting a customizable and extensible framework which essentially consists of process-based analysis modules such as machining, which is milling, casting, molding. Then you have turning, additive manufacturing, and so on, which essentially is run, or the backbone of which is the feature recognition or the thickness sort of engines, which validate certain critical areas of your design and help you to bring out a rule framework which can be configured and tailored to specific requirements. So with this, a framework built in within Siemens NX, working in tandem with Checkmate within NX, what you are getting is essentially an outcome which is DFMPro, which has out-of-the-box packaged DFX rules, as we will see during our demonstration. But along with that, you get a facility to configure those specific out-of-the-box industry best practices to suit your requirements, and also generate effective and quick reports which can be shared for easy collaboration with various stakeholders within your design to manufacturing cycle. So at the end of it, what you're essentially getting or giving the design engineer is organizational custom best practices so that he can take the right decision right during the design stage and ensure that he's avoiding all the challenges that we have seen earlier. So look at DFMPro as a more of a platform and how you can build on top of it, because the opportunities are effectively endless. Now, any of you who might be familiar with how DFMPro works, might have seen this particular framework in place within NX. But for those who are not aware, essentially what you are getting as a design engineer is a unified design framework within NX, coupled with the three sort of important items which bring in this as a complete unified framework for the design engineer. So what you are getting is essentially DFMPro, which works closely with Checkmate, which essentially is a modeling standards solution within NX. DFMPro again, which is essentially a strictly manufacturability validation solution, which can validate your designs for various manufacturability requirements, catering to the various processes that are highlighted in front of you. And recently what we have also done is we have introduced a new module for composites, that is composite design, and that is where the FiberSim interface within NX comes into play. So we are trying to essentially, for the NX users, we are trying to build in this ecosystem which organizations can leverage to validate or to take care of the manufacturability requirements of designs for all the various processes that are highlighted. So the FiberSim is something which is recently added, and we have started supporting composite-based rules, which we will cover in future. So I think this is the most important slide. I mean, if you see, just to give you a complete overview of what we are doing with DFM and how a design engineer can benefit. So imagine you are a design engineer creating and modifying your designs. What you essentially do is you pass the design through the DFMPro for NX plugin, which is built in within NX. Now DFMPro, as mentioned, is essentially a knowledge database of best practices, which you also have the possibility to populate based on the downstream requirements. So you have the sourcing, manufacturing, and the supply teams requirements, which can be built in inside that knowledge database. And once the knowledge database is customized to a particular company's design guidelines, DFMPro, what it does is it essentially validates that particular design based on these best practices, throws out a quick manufacturability report within NX, which the design engineer can consume right there itself. Since he has access to the model tree or the feature tree in front of him, what he is getting is essentially a quick feedback on how we can not only which are the problem areas, but how we can actually improve on those particular problem areas. So he makes the necessary changes to the design, and as soon as he is essentially sure that he has covered all the features, he then releases that part or optimized design for manufacturing. Now, typically what we recommend is not to run this at the end of the design, but the idea is that you run this iteratively at various design stages when you are adding features on a, say, for example, a day-to-day basis. And that's the best time to run the solution, because it's essentially going to ensure that you are improving your design productivity and making sure that you are taking care of all these supplier best practices right at that particular stage and not at the end of the design. So I think with that, let's quickly move on to some of the capabilities of DFMPro within NX. And for this, I will quickly switch on to the DFMPro framework within Siemens NX. Now, this is a Siemens NX 11 version. We also support in NX 12, which is the latest version. So it doesn't matter which NX version you guys are on. You can still basically leverage all the capabilities of DFMPro within NX. So if you see here, what we are basically going to look at is this particular component, which is in its intermediate stage of design. Essentially, it's a machine part, and what we are essentially going to see is how some of the features that I've added on this design can be improved for manufacturability. Now, basically, you find DFMPro here right inside NX, and you get this advanced toolbar, which contains all the manufacturability processes listed inside this particular toolbar. You can also find DFMPro through the application and Checkmate interface, wherein you more or less get the same workflow, but it's essentially tightly embedded within the Checkmate interface. So for this particular machine part, what I'm going to do is my rule file is already set up. We will be taking a look at this particular rule file quickly in a while once we complete the workflow. But this rule file is essentially the best practices that I as a design engineer am supposed to follow. And what I'm basically supposed to do is at periodic intervals of my design process, I should basically run this design for the rules that are configured, get quick manufacturability feedback on what I have created, whether it's meeting the set guidelines or not. If not, then quickly correct them and proceed with the next phase of design creation. So at this stage, what I'm essentially going to do is I'm just going to go in Prismatic Mill. I'm just going to click on Prismatic Mill module. And what happens is the feature recognition runs in the background. It validates your design based on the features that are present and compares those features against the rules that are selected within your rule file. And then if there's a mismatch or if there's a violation, it's essentially going to show you the results both in the checkmate window here, that is HD3D tools, and then also in this advanced result view toolbar, which is essentially going to show you areas which can be improved based on the current best practices which are configured. So if you see here, if I click on any of this root node, it's essentially highlighting to me all the sharp corners, sharp internal corners that are currently present on the features that I've essentially added. Now, there will be areas or cases where, during my design phase, due to, lack of time or, due to work pressures, I might forget some of the sharp edges and eliminate them by adding, certain respective radii to it. So with this, what I'm getting is I'm getting an idea of what essentially is going to get hampered if I have sharp corners on my design with a quick explanation about it. And then I click on the individual instances. I click on that specific area. It's showing me that in this particular direction, I have sharp internal corners in this particular pocket. And it's giving me the same message here that sharp corners are present, so avoid sharp corners. Similarly, if I look at the other instance here, I have some sharp corners at this particular area as well. Now, since I'm within NX, that's the beauty of this, that I have access to the model tree here. What I'm essentially going to do is, as soon as I see sharp corners, I'm basically going to go in. I'm going to quickly eliminate these sharp corners based on certain radii that I feel should be added to this. So what I'm doing is I'm just going in here. I'm adding a certain amount of radii to all these specific areas, and what I'm basically getting is a framework or an opportunity to improve my design quickly to eliminate these sharp corners. So I am quickly eliminating all the sharp corners on this particular pocket with a value that has been specified in that particular area. So I've essentially eliminated the sharp corners, and now I say okay. So I've basically added the fillet radii at the end. Now, if you see essentially for this particular pocket, adding a fillet radii of 1.4 mm may not, be valid, because essentially depending on the pocket depth, you have to define what the side radius has to be, because essentially if for such kind of pockets it requires long end mills which are essentially prone to breaking and also increase the overall cost of manufacturing. So as a design engineer, I am aware that the depth of this particular pocket is 24 mm because that's how I had created it. So as per standards, essentially to achieve the depth to side radius ratio of less than or equal to 16. So that's the standard out of the box guideline which is supposed to be followed, and again that is configurable as per your requirements. But in order to achieve that particular depth to side radius ratio, I need to either reduce the depth to below 22.4 mm. So depth of this pocket has to be reduced by 22.4 mm, or increase the radius of at this particular sharp edge to at least greater than or equal to 1.5. So right now we have added a radii of 1.4 at this particular area because that was essentially feasible for the depth of this particular pocket. But if I add the similar radii here, essentially it's going to give me a quick warning that you need to change that radii because it's going to hamper the secondary rule, which is a deep radii corner. So what I'm now going to do is I'm essentially, instead of adding a radii of 1.4, I'm going to add a radii of 1.6 mm at this particular location, because that is what the guideline essentially is telling me, to add a side radii of greater than 1.5. So I've added a side radii of 1.6 here. And again, this can be done, done in tandem with discussions with your manufacturing downstream teams. You can quickly take inputs from them by creating quick reports and sending those reports out to them, and get a validation of whether what feature you are adding is as per their expectation. So I have essentially added the radii for this particular area, and now what I'm going to do is I'm just going to save this particular area design, and now I'm going to rerun the analysis. So what I've done is I have made changes to two areas of design. I have essentially eliminated two sharp corners on my design. First was this, which has been now corrected, and it's no more flagging for recommendations. And then the second is essentially this pocket, which I have again modified. So if you see here, initially there were 3 instances, and now essentially I have just 1 instance remaining to eliminate the sharp corners from. And again, as I mentioned earlier, you have a chance or choice to essentially discuss this with your manufacturing teams by generating reports, or you can, based on your understanding of the design as well as the functional requirements, this particular sharp corner can be eliminated quickly based on, the values that are supposed to be added. Another thing, essentially, if you see on this machine component, you have some tolerances which are added to some of the holes on this particular design. Now, many of the organizations, especially the aerospace and defense customers, what we have seen is they're moving towards the MBD or MB initiative, that is model-based enterprise. And what they're essentially trying to do is get rid of drawings and have the 3D as their master. So in that case, what you will essentially have to do slowly is add tolerance information for all the features on your 3D part, which will essentially be consumed downstream by manufacturing teams. But what we have seen is that is still a relatively new concept, and it will be a while before that becomes a norm. But with DFMPro, you already have the capability to validate your designs from manufacturability, from an MBD point of view. So for this particular hole, what is essentially telling me is that the tolerance that I've added on this particular hole, that is the size tolerance for this hole diameter, is currently 0.01 to minus 0.01. Whereas ideal recommended tolerance for holes of such diameters is within this range. Now, what you are essentially getting is essentially a quick tolerance feedback, whether you are adding too tight tolerances or whether your tolerances are within a defined range. Because eventually you want to make it easy for the downstream teams to manufacture the features on your design based on the tolerances that you are adding. So with DFM, you are also getting that kind of feedback. And if you are adding PMI data on your 3D files, then essentially the framework is in place or the platform is in place to create as many custom requirements for these particular tolerance related rules as possible. Now, if you see, this is a positional tolerance recommendation that's been thrown out, and this is currently violating the recommended value. So I think more or less you might have got a good idea about what we are trying to do. Essentially, what you're trying to do is you're also trying to give a quick collaboration mechanism. So you can, if you are not sure what this particular recommendation is and whether you need to change this, you can add it quickly to a report, take an image of that particular instance, and eventually once you have added or reviewed your entire design, you can quickly generate a report out of this, save it at a convenient location, and then once that report is generated, what you are basically going to do is send that report via email or your preferred way of sharing to the downstream teams for a quick feedback. So this is the Excel report. It's basically telling you which design engineer created it and what were some of the recommendations which were identified on it. As you click on that individual rule, it highlights or takes you to that individual sheet, adds that image automatically within the report. You get the comment that you had added embedded within that report. And the last 4 columns essentially can be used by somebody who wants to give you a feedback, or if the question or the person to whom the question is intended. So if, say for example, a person sitting in China is sending me that this is okay for manufacturing. So now I basically know that okay, this particular feature or the tolerance that I've added is okay, and I don't need to make a change to this particular tolerance, although DFM has highlighted it through my rule configuration. So he will send this report back to me, and then I have a clear picture of whether this was supposed to be corrected or not. And then what essentially you can also do is attach this particular Excel report along with the part inside your PLM system. So if you're using Team Center or if you're using any specific other PLM system, that can be attached to that particular part, and you basically get a historical information about how or what kind of DFM analysis that component had gone through. So this was from a machining point of view. I also want to quickly give you a glimpse of a plastic part. I think we are nearing the end of the presentation, but I think we have sufficient time to cover a couple of more modules. So the plastic part design is something which is an extremely I would say powerful capability within DFMPro, and I think the more or less the process remains the same. The rules that are configured here are in place in that same rule file. I'm going to select my primary direction, that is the primary direction to extract this part from the mold in terms of core and cavity. I can also add multiple secondary directions based on the side core features or the cores that are going to come in and create this particular design. And once I've done that, I have essentially running my injection molding validation to quickly give me a feedback. So till the time it runs, I think it just takes around a few seconds to run. But this is essentially the rule manager that you see. And apart from machining and injection molding, you can see other various processes that are supported, like additive manufacturing, assembly. So in assembly, you can do checks like hole alignments, interferences, clearances, fastener related checks, standardizing components, hole to slot alignment, and so on. Apart from that, you get casting guidelines. Then you get injection molding guidelines, as I mentioned earlier, machining guidelines, sheet metal, and as you scroll down, you get tubing, tolerance, and turning guidelines. And again, this is just a platform, and any specific guidelines to your organization can be added to this particular framework. So the validation for injection molding is complete, and essentially what you're getting is recommendations whether you have added radii at your tips of the radii for all the bosses at its tip. Because essentially if you have not, then over a period of time during manufacturing or during operation, there's a chance of breakage. So you essentially get a quick feedback of whether there's a fillet radii added. If not, it's telling you how much radii should be added so that this meets the manufacturability requirements. Similarly, draft angles. So draft angles both at core, cavity, as well as side core are validated. And based on the best practices defined, you have the values in those rule configuration windows populated, and you get a quick feedback whether you have added sufficient draft or not. So at core side, you have, for this particular feature, there is 0 draft, whereas recommended is 0.5. At the cavity side, essentially what you are getting is, from a cavity point of view, the draft ideally should be 1.0, but it's currently 0.0. And all these values that you see here are configurable, so you are essentially in good hands. And the other requirement for this particular component is mold wall thickness, which means whether the thin steel condition on my design is achieved or not. Whether my features like ribs and bosses, are they too close to the walls of this particular component? Because over a period of time, the thin steel condition is going to affect and wear down the mold and affect the quality and reduce the lead time. So just to show you a quick glimpse of the DFMPro rule manager. So this is how the rule manager looks like. You get a configuration window wherein you can configure and change the values. So if you feel this value is something that needs to change based on your company requirements, that can be directly done at your side. You get a facility to define the priority for all these various rules, as well as you get quick access to the help, which is a great way of educating not only yourself, but your new design engineers on the best practices that are supposed to be followed for manufacturability. So you get a definition of the rule, you get explanation as to why that rule is important, and a general industry recommendation as to what is right and what is wrong. And on the left-hand side, you get access to all the knowledge base, which is currently present in DFMPro. So hopefully, I think you have got a flavor of what all things DFMPro can achieve. There are numerous, more rules which you can access and make use of. You can also access some of its other features like, exporting the results. So these results essentially can be exported and saved, inside your PLM systems. so that you don't have to redo the analysis again, or if somebody in future wants to see what kind of DFM analysis was done on that particular component, they can quickly extract the historical results, and they will, as soon as you open the part, you have the results populated in front of you. So you also have that particular facility. And then you see all the various processes here: assembly, casting, die casting, molding, machining, sheet metal, mill turn, tubing, additive manufacturing. There's a lot of interest from many of our customers for additive manufacturing, and working closely with them, we are now able to build the knowledge database for additive manufacturing. You have sand casting, investment casting, and composites is something which is new, as I mentioned earlier, and soon you will basically hear more about composite module within DFMPro for NX from us. So do look forward to that. So coming back to our presentation, and to summarize what we have seen till now, is essentially with DFMPro for NX, what you are getting is a platform-based approach to solve your design and manufacturing related issues. It's essentially a scalable platform with out-of-the-box design and manufacturing rules with scope for customization. So as I mentioned earlier, don't look at it as just an out-of-the-box solution, but look at it as a platform on which you can build and cover as varied requirements in terms of DFM or design that you can think of in your organizational framework, and the solution we will be able to help you to add all those specific custom requirements. At the same time, what you're doing is essentially standardizing your design process. I think that's one of the key challenges and targets of many customers around the globe as to how they standardize the design process. Supplier consolidation and capturing downstream best practices is extremely key, as I mentioned earlier, so that you are taking the right design decisions. Targeting the highest contributors to ECOs and ECRs, that is engineering change orders or engineering change requests, for most common manufacturing techniques is possible through a platform like DFMPro. Access and build capabilities towards latest techniques like additive manufacturing and composites. So it doesn't matter if you are dealing in a completely new environment or a new domain, or if you're dealing with new manufacturing techniques, you still have the capability to address it through this platform. And then essentially build a knowledge base and train your in-house design engineers so that they're well accustomed to manufacturability or techniques. So I would like to thank everyone for joining this particular webinar. It's always a pleasure, and hosting such kind of webinars, because we'd like to showcase how our solutions can help you in your organizations. Feel free to drop us an email at dfmpro.marketing@hcl.com if you have any further questions in terms of how we can bring in this solution within your organization. Do visit our website dfmpro.com for more information about the solution. You can also find few videos there. So thank you so much again for your time.